Hey everyone, and welcome back to CodeMechanic. Today, we're diving deep into a critical component under your hood. The mass air flow sensor, or MAF sensor. This little guy is basically the lungs of your engine's computer, telling it exactly how much air is coming in. Why is that important? Because the engine needs to match that air with the perfect amount of fuel for efficient combustion. Get that mix wrong, and you'll notice problems like poor fuel economy, rough idling, or a serious lack of power. So, how does it work? Most modern cars use a hot wire MAF sensor. Inside, there's a tiny, heated wire. As air flows past it, the wire cools down. The sensor's electronics then pump more current into the wire to keep its temperature constant. The amount of current needed is directly proportional to the mass of air flowing into the engine. This information is then converted into a voltage signal or a frequency that gets sent straight to your car's brain, the engine control unit, or EC. A healthy MAF sensor at idle might read around 0.6 to 1.2 volts. And when you stomp on the gas, that voltage should smoothly climb up to 4 or 5 volts, showing the engine is gulping in more air. Now, let's talk trouble. If you see check engine light codes from P0100 to P0104, your MAF sensor is waving a red flag. P0101, for instance, often means the sensor's reading is out of the expected range, while P0102 indicates a low input, and P0103 means a high input. These codes don't always mean the sensor is dead. More often than not, it's just dirty. Over time, things like oil from a crankcase ventilation system or dirt that sneaks past a cheap air filter can bake onto that delicate hot wire. This contamination acts like an insulator, making the sensor slow to react and underreport the amount of air coming in. The ECU, thinking there's less air, injects less fuel, and your car starts to feel sluggish and underpowered. So, how do we confirm the MAF sensor is the culprit? Grab a multimeter. It's your best friend for electrical diagnostics. First, with the key on but the engine off, you can back probe the connector to check for power and ground. You should see a 5-volt reference or 12-volt battery power, depending on the system, and a solid ground connection. Next, start the engine and let it idle. Back probe the signal wire. As we mentioned, you should see that low voltage, typically around 1 volt. Now, have a friend gently rev the engine while you watch the voltage should rise smoothly with the RPMs. If it's jumpy, flat, or doesn't change, you've likely found your problem. A scan tool that can graph live data is even better, as it lets you see the sensor's response in real time. Okay, let's say the sensor's just dirty. Don't rush out to buy a new one just yet. Cleaning it is often all it takes. But please, do it right. Do not use brake cleaner, carburetor cleaner, or anything other than a dedicated MAF sensor cleaner. Those other chemicals can destroy the sensitive electronics or leave a residue that makes the problem even worse. To clean it, carefully remove the sensor from the air intake tube. Usually, it's held in by a couple of screws. Once it's out, hold it carefully and spray the cleaner generously onto the hot wires and any other sensing elements inside. Give it 10 to 15 good sprays from a few inches away. Do not touch the wires with anything, no brushes, no cotton swabs, nothing. They're incredibly fragile. Let the sensor air dry completely for at least 15 minutes before you reinstall it. Don't use compressed air to speed it up. Once it's dry and back in the car, clear the trouble codes and take it for a spin. You'll probably be amazed at the difference. And that's your crash course on the MAF sensor. Understanding how it works and how to test and clean it can save you a ton of time and money. If you found this guide helpful, hit that like button, subscribe to CodeMechanic, and ring the bell so you don't miss our next video. Thanks for watching, and we'll see you in the next one.